Okay, I would like to provide you some hints on some of the homework problem. I assigned 26 to 28. 26 and 27, they are quite similar. So I would like to focus on 27. Just for convenience purpose, I copied the question to here. So let's read through the question. This equation is so-called the ordinary annuity equation. Here this A is the amount of mortgage, P is the monthly payment, I is the interest rate per period for the N is the payment period. So if you use if you pay each month, then M is the how many months that you want to pay off the mortgage, and I will be the monthly rate, monthly interest rate. Now with that, let's take a look at this problem. So there's a 30-year home loan, home mortgage, and this is the amount needed, and the borrower will pay 1,000 per month, and we want to figure out the I. So put it in another way, A is so put it in another way. Now A is 135,000, right? So this is the A, and P is the monthly payment, which is 1,000, and I is the interest rate that we are trying to figure out. 1 minus 1 plus I raised to power negative. N is the number of payments period, because we are talking about 30-year home mortgage, which means and payment is made monthly, so which means 360 months. Now, of course, this is going to be 135,000. So we want to find the I. That's the I we want to solve. And this is pretty tough to solve because you can see that the power is pretty big. The I and I, they're separate. There are two I's in the equation. So we want to solve this using our computer program. In order for you to solve that, you first convert that to a root finding problem, right? So now, what is your f of x? This is what we want to do. By looking at this equation above, we can rewrite this as, first of all, at least something I can do is to eliminate this I. Sometimes removing I in the denominator may be a good idea. So I can rewrite that as 135,000 times my I equals 1,000 times 1 minus 1 plus I raised to negative 360. And then I continue to convert this to a root finding problem. So maybe I can write that as 135,000 I minus 1,000 times 1 minus 1 plus I raised to power negative 360, right? Equals 0. So do you see that now I have f of x equals 0. This is the root finding problem. And then to solve for x, I would like to use Newton's method, because this whole section is Newton's method. And what is f of x? I would like to type in. This is the f of x. Okay. So with that, I'm gonna type in my equation. This guy here. So I use my Newton's method. I think I write 135,000 times my I. So just want to make sure that because I define f of x, I use variable x. Instead of I should type x. Minus 1,000 times 1 minus 1 plus x raised to 360. So this is the equation I just derived previously. So I want to type this in my Newton's method, this program, and I just run it. So this is the graph, and then I want to pick an initial value. Use your common sense, because this is the mortgage interest rate, right? That's monthly rate. Monthly rates, that's not annual rate, it's monthly rate. So even with so you should pick a value close to 0, not close to 1. I pick up just 0.05. Why? It's no reason, just random value. Of course, I would not pick 0.9, right? It's impossible. That monthly mortgage rate is 90%. That's almost impossible. So I'll just pick a number 0.05, I'm sorry, or 0.01, up to you. And I'll run my program, and this is my output. Okay, so this is my output. After 4 iterations, my accuracy of the approximation is accurate to 10 to the -5 already. This is my tolerance. Now keep in mind, the question actually is asking what is the maximal interest rate. This is the annual rate. Okay, it's not the monthly rate. So once I find my answer here, I have to multiply it by 12. Okay. So I would like to 0.0675. That's the approximation that I have. 0.00675 times 12. And let me make it bigger. Okay, so after multiplying by 12, the annual interest rate we found is 8.1%. So this is the how I would solve 27. Now, when you solve your problem, I would like you to absolutely do. I will not allow you to use this as your initial value. Use some other value to solve this problem.